Okay, this is the video explaining using factoring, solving quadratics using factoring. Here's the biggest part. Here are the key features. It's all about finding the zeros, okay, to get something into factored form. Factored form, so the one where we have parentheses, that's a multiplication problem. We have something times the other thing, something else, okay? And if you look through your note sheets, all of them are timesing problems. And that's why it's factored form. It's written as a product of two or more expressions or two or more things. It's just factors are parts of a product. They're two things that you multiply together. Expanded form is when we're adding and subtracting, okay? It doesn't tell us the roots. The nice thing about factored form is that it tells us the roots. And then the easiest way to think about this is if I say, guys, I need two things that multiply together to get me 0. You'd say 1 times 0, 0 times 5, 8 times 0. 0 times 18. One of those always has to be 0. Okay, we can't multiply two things together and get 0 without one of the two things being 0. So let's look at it in some of the examples that we did in the video. Okay, if I wanted one of these two things to be 0, now let's think about just x minus 9. What makes, these are my two things. This is my A, this is my B. What makes just x minus 9 0? Well, if x were 9, then that would be 9 minus 9, and then this would be 0, and game over, this whole thing becomes 0 because one of the things is 0. If one factor is 0, then the whole thing is 0. Okay? Then if we want the other thing, the B, if we want to talk about it that way, could be 0 as well. So what makes 3x plus 4 0? Well, if you look later in my work, then we have 3 equals a negative 4x, and those are my, and we're going to have negative 4/3 equals x. And what's nice about that is that it tells us on the parabola where y is 0, what x is. So that means this parabola is going to hit the x-axis at 9 and at negative 4/3. That's why we like factored form. It tells us our roots. Okay? So I'm going to skip B and kind of move on here. Here's where I went through and I found the roots, and we'll go to where I have some work, at least through the first two here. The first one here is a binomial. Okay, if you remember, a binomial has two terms. This is way back at the beginning of the year. A binomial has two terms. So we only have x squared and negative 2x. We want to see, this is an addition and subtraction problem, or a subtraction problem, so it's in standard form. We want factored form. We want to see what makes us be zeros. Okay, we want to find the zeros. So what they did here is they undistributed. You guys know the distributive property, x times x equals x squared, x times negative 2 equals negative 2x. So we undistribute and we get into factored form. And when we have a binomial, you'll have one set of parentheses and then one just term out here. Okay, over here, this is a binomial. Once we minus x from both sides, 5x from both sides, then we have one set of parentheses. Okay, and usually in the binomials, you'll have one of your roots be 0, because what makes this part 0? 0 does. If it's just x, then 0 is the only number you can sub in for x that will make that 0. And then what makes this 0? 2. 2 made that 0. Over here, what made x 0? 0. What made 2x minus 5 0 happened to be 5/2. Okay, so that's the binomial part. When we get into the trinomials, so these second two examples, this is where I heard a lot of people saying, I want a formula. How do I just do it? Okay, and some of you were saying, I want to understand it. What are we actually doing? What's the purpose here? Well, the purpose is to get it into factored form to find our roots, to know more about the parabola, to know that this parabola will cross the y-axis at 0 and at 2. This one will cross at 0 and at 5/2. This one will end up crossing at -5 only. It will have a vertex on -5. This one will end up crossing at x, or at 3 and -14. So it tells us more about the parabola, and we're going to get into that because we have 3 different forms of quadratics, and this is an important one, okay? The biggest part here, when you have a trinomial with a coefficient, a leading coefficient, so this first part is just 1x squared, then you can use factoring, okay? Sometimes you're not going to be able to use factoring, but if it's nice, you can use factoring. And I know you've gone over this and with Miss Mar, that to use factoring, we go back to those boxes that we used when we were foiling. Factoring is the undoing of a foil, or foil is the undoing of factoring. So when we foiled, we took x times x, that gave us x squared, 5 times x gave us 5x, 5 times x gave us 5x, 5 times 5 gave us 25. Okay, if we were foiling this over here, x times x gives x squared, -3 times x equals -3x, 14 times x equals 14x, -3 times 14 equals -42. That was foiling. You remember when you did the first inside, outside, last, or you set up these boxes? Okay, factoring is the undoing of that. And to get that factoring, we look at the product, or the factors of this number, and the things that sum to this number. What's nice is that there's a lot less things that multiply to a number than there are add to it. Okay, so we look at what are the factors of 25, and do any of those factors happen to add to 10? In this case, it was 5 and 5, so we only had one root of -5 because -5 made both this and this 0. Okay, so that means our parabola would come right down on the x-axis and then go right back up at -5. Over here, what are the factors of -42? We had 21 and 2, 14 and 3, 7 and 6, but now since it was a negative, we knew one of those had to be a negative number. We knew one of the factors had to be negative, and then they had to add to a positive number. So what of these two? We decided that 14 and 3, if the 3 were negative, they would add to 11, and they would multiply to -42. So we made the 3 negative in here, and we had x minus 3 and x plus 14. Now, what are the roots that make that true? What makes this 0? 3 does. So 3 is one of our roots. What makes this 0? -14 does. So that one of our roots is -14. That will be something that a lot of you forget. A lot of you will get to this point, and then you'll think your roots are -3 and 14 when they're actually the opposite. Roots are what make the problem 0. Roots are when y equals 0. If we think about the parabola, the roots are the 2 points where y is 0, or the 1 point where y is 0, or the no points where y is 0. Okay, does that help a little bit? I hope so, and I can't hear your response, but yeah, we'll talk more about it. You guys are asking good questions. Just try not to get frustrated.